So now let's talk about what makes a good graph and what makes a terrible graph. So you will probably start to see these now that we know what these will be. You'll probably start to see them in on the internet. You'll see these on commercials, on the news. People tend to like to misrepresent graphs and make terrible graphs to manipulate the regular people. But we're not regular people anymore. We're smarter than that. So here are some lists of things that are pretty good to think about when we're trying to make some good graphs. So, first one, you want to make sure that you are always labeling and naming your axes clearly. So remember, the axes are the left side and the right side, right? You need to make sure we know what these actually are. Providing some explanation if needed. Remember to include the units. So are we in miles? Are we in feet? Are we in degrees Celsius? That's always going to be important. So include a meaningful title, right? Just having a graph isn't going to be helpful if we don't know why we're having the graph. Super important, make sure to avoid distortion. So don't lie about data. There's a couple different ways we can do that. And we'll talk about a little more later on. But yeah, just flat out lying about your data, that's not great, obviously. Make sure to minimize the amount of white space in the graph. So make sure to use the available space to let the data stand out. So, for instance, if you have a graph that looks like this, there's so much white space, right? We could probably make that y-axis, we can kind of cut it off a little bit, stretch it, give it a little bit more pizzazz. So, super important, if you truncate, so truncate means to cut off, so if you cut off the scales, clearly indicate this to the reader. So if you're not starting at 0, you need to make sure to tell the reader you're not starting at 0. And typically the way we do that is using a, there's not a technical word for it, so I like to call it a doo-doo-doo. So when you go up, you go doo-doo-doo. A little break in the graph. It tells you we're not starting at 0. All right, make sure, again, to avoid clutter. Right, so excessive grid lines, unnecessary backgrounds, they could look really cool, but backgrounds and pictures are going to just ultimately distract from the data. Remember, the data is the thing that we need to look at. So let that be the thing that stands on its own. Another one, avoid three-dimensional graphs. They may look pretty cool, but they actually distract the reader and often lead to misrepresentation of your graph or misinterpretation. Yeah, the 3 dimensions has an extra dimension, so things are going to look extra, proportional. So things might look a little bigger difference than they actually are in reality. So just avoiding the 3-dimension graphs will be good. We'll look at some examples after this. So 2 more, and then we'll look at some examples and kind of apply this. So next to last, do not use more than one design in the same graphic. So sometimes graphs use different designs in one proportion, or one portion to distract from the others, right? So don't try to distract the reader or force the reader to look at a specific part of the graph. Let the data speak for themselves. So, readers are pretty smart. They should be able to read the graph. So if you have a bunch of bar graphs, for instance, you don't want to make this one a different color. If this one's the one you're emphasizing, right? You just want to make all of them the same color. So that would be incorrect. And this you do see on commercials all the time, right? They'll emphasize their brand against all the other ones. Not great. And lastly, avoid relative graphs that do not contain data or scales. Right? If there's no data, then there shouldn't be a graph. All right, so let's look at some of these problems. So problem number 10 on our worksheet. A home security company located in Minneapolis, Minnesota, develops a summer ad campaign with the slogan, "When you leave for vacation, burglars leave for work." According to the city of Minneapolis, roughly 20% of home burglaries occur during the peak vacation months of July and August. The advertisement contains the graphic shown below. Explain what is wrong with this graphic. All right. So this one's a little tricky. So some people might say, oh, well, it's a horizontal bar graph, right? It should be going up. Well, horizontal bar graphs actually are okay. So it's okay for these graphs to be horizontal. I just simply don't do it that way, but doesn't mean you can't. That's totally okay. All right. So what else could be interesting with this graph? So if you notice, right, here, what percentage do we have? We have 20%-ish. What percentage do we have here? So this is about 8%, right? What's interesting about that? What might be a problem with this? So 20% and 8% is 28%. Why is that might be a little weird? Because it should equal 100%, right? So this is a misleading graph. Everything should add up to 100%. Percentages should add to 100%. That's a huge problem. Hopefully that makes sense. Okay, so if we actually want to see what they're doing, so this is really all I need to know for what's wrong with the graphic. They don't add up to 100%. But if we actually look at what's going on, right, we can see that 2 of the months has about 20%. So how many other months would there be? There'd be 10 of them, right? There's 10 other months in the year. So if each of these 10 months has about 8%, so you see that's what they're doing. They're combining 2 of them, but then each of the other ones are just leaving it alone. So 10 months times about 8%, that gives you about 80%. So the 20% and the 80%, that's how we get our 100%, and that's what they were doing, right? They combined 2 of the months to accentuate it, accentuate it, I don't really know what the word is. Oh well, to highlight it. That's a good one. And then all the other ones, they just kind of average them all together and put them as one graph or bar graph. But that's terrible. In actuality, this is something that would look better. Now, you don't necessarily need to write this down or anything, but this is something that looks a little better, right? Every single month is represented. 2 months aren't pushed together. And if you actually realize, right, they were saying that July and August occurs more often than not, right, for burglaries. But if we look at it, July and August, I mean, July definitely has the most, but August, there's a lot, right? Even September and October are more than August. So sure, if you add these 2 bar graphs together, it's going to look like there's more in these 2, but you could actually do that for most of these graphs, right? You could add these 2 bar graphs together and it would look more than all the others. Or you could add these 2 bar graphs together and they would look more than the others, right? So yeah, this is a better representation of a graph. And if someone tried to pull this one off, it would be terrible, right? They're trying to misrepresent their data, which is a no-no. So this is what the better graph would look like. All right, let's look at example number 11. A national news organization developed the following graphic to illustrate the change in the highest marginal tax rate effective in January 1st, 2013. Excuse me. Why is this graph considered misleading? So this is going from 2012 to 2013. So if we look at this graph, right, if we look at this bar, how many of these should be able to fit in here? How many of these bars would be able to fit in this bar? Well, actually, you can see, right, if this is 1, 2, 3.5, so it looks like this, or we could say it looks like 2013 is 3.5 times as much as 2012, right? That's what the graph is telling us, or that's what the graph looks like. However, if we actually look at the graph, what number is 2012? Well, it's only 35%. What about 2013? That's 39.5%. Do you see how this is not even close to 3 times as much? Yeah, so this is what politics does this all the time, right? Oh, look at how much bigger the tax rate has affected just 1 year, right? The new president has changed taxes, it looks like, by 3.5 times as much, but in actuality, it's only about 4 or 5%, right? So the reason why this is bad is because they truncated the bars, right? They didn't start at 0, and they didn't tell us that they didn't start at 0. So this makes the bars look abnormal. Any of these is correct. You could write they truncated the bars. You could say that it looks like it's 3.5 times as much, but the numbers don't add up. But the actual numbers are 35% and 39.5%, right? Just something like that. Just tell us what's wrong with it. So this would actually be better, right? This is a graph that starts at 0. And when you look at the comparison, right, this looks a little bit more fair. 35, 39.5. This is the better graph. Number 12, bar graph shown in the USA Today type graph. The survey was conducted by Pulse Research, in which individuals were asked how they could flush, or how they would flush a toilet when facilities are not sanitary. What's wrong with this graph? So there is obviously too much stuff in the background, right? It looks, interesting. Maybe something that, if you're first time making a graph, this might look fun and interesting, makes it pop, but unfortunately there's too much stuff going on. Right? There's the background, there's the toilet rolls, right? And it's all just ultimately very distracting. We can also see that the numbers don't add up to 100%, right? Which might be bad, might be okay, right? We can actually see, well, what do they add up to? So, oh yeah, it's only 88%. So that's not great. Percentages don't add up to 100% either, right? So they missed some data. Yeah. Good. Also, if you notice, the toilet paper themselves kind of isn't super representative, right? 17, that's almost that's just over half of 30. But when you look at this, right, this doesn't look nearly as half of 30. So the bars also don't really make any sense. Yeah, lots of things wrong with this one. All right, number 13. Soccer continues to grow in popularity as a sport in the United States. In 1991, there was approximately 10 million participants in the United States aged 7 years and older. By 2009, this number had climbed to 14 million. To illustrate this increase, we could create a graphic like the one shown. What's the problem with it? So what's the problem with this graph? Hopefully you can see so many things, right? There's no data on this graph. This tells us nothing. There's no axes, nothing's labeled. It's just a ball and another ball. Like, that's bigger. That doesn't really tell us anything. Also, we can look at it, right? How many balls do you think you could put inside the 2019 or 2009 one? How many of these could fit in here? So maybe 3 or 4 times as much. So the 2009 ball is 3 times or 4 times as big as the 1991 ball. However, what are the actual numbers when we saw it? 1991 was 10 million. 2009 was 14 million, right? That's not even twice as big. So the actual data, the numbers, don't align with this. All right? Yeah, this is just a terrible graph in general. Better graph would have been just a standard bar graph, right? Tells you your data. Here's your axes, right? So much better. All right, last one. The figure represents the educational attainment levels of education in 2016 of the adults 25 years and older who are in the United States. Why might this graph be considered misrepresentative? So even though it looks really cool, right, we can see there's 3 dimensions to this one. And that's not great. So the way that 3 dimensions work, right, typically the thing closer to you looks like it contains more data. So this one, just by perspective, looks like it might have or might contain more data than it actually does. Right? That's just the optical illusion of a 3-dimensional graph. But if you rotated any of these around, it might look like that one has the most. So yeah, even though this looks kind of cool, it's a problem because it has 3 dimensions. So the better way of doing this is just a regular old pie chart, right? Doesn't look nearly as cool, but it's way more understandable with what's going on. All right, that was the last one. As always, if you have any questions, let me know.